Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of determining slope. This is standard A.3A in the great state of Texas, and we are using item number 17 off the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a table of values, and we have a linear relationship here between x and y, so we need a slope, right? So slope is, remember, our change in x on the bottom, our change in y on the top, to keep that in order. Right? We'll normally say rise over run because our y coordinates rise up and down, our x coordinates run side to side. But really, when we're wanting to turn it into an actual equation, this is what it looks like. Y sub 2 minus y sub 1. So we're going to just take two different y coordinates, subtract them, find the change. Now we have to find our x coordinates that match those y coordinates. So if they're not paired together, it's not going to work. But here's the thing, you've got a table of values. It really doesn't matter which set you do. So let's just start with this. Let's just say this 9 is going to be my y1, and then this 1 is going to be my y2. Now in order to make this work, the negative 7 needs to be my x1, and the negative 2 needs to be my x2. They have to be paired side to side. The 1s and the 2s have to be together. And if we'll go with that, we'll get it very simple. What I want to do is show you, does it really matter which set you use? So my y2 is going to be 1. So this is why you label them, because you have to put the y1 and y2 in the correct spot. So my 9, there we go, is going to be minus 9, and then I've got my negative 2 as my x2, minus, and then I've got a minus negative 7, so that's going to end up being positive 7, right? Okay, so I'm going to get negative 8, and then negative 2 plus 7, because it's minus a negative, so that's like 7 minus 2, that's 5. All right, so I get negative 8 over 5, which we can just, since it's just right there, we can move it to right there, negative 8/5. That's what it looks like. But I said it doesn't really matter. So let's not use these anymore. I want to use two that are not adjacent. So I want to make this be my x2. I want this to be my y2. I want this to be my x1. I want that to be my y1. So let's see if I get the same thing. If it's the same line, the slope should be the same no matter which x and y coordinates I use. So my y2 is going to be 1 minus my y1 is, wow, negative 15. And then my x2 is negative 2 minus, and then I've got 8. Okay, so 1 minus negative 15 is really like 1 plus 15, right? So that's going to be 16. And then negative 2 minus 8, so that's like adding two negatives, that's going to end up being negative 10. We do need to simplify that. Those are both even, divide by 2, 8 over negative 5, and look at that. It doesn't matter whether the negative is in the numerator or whether the negative is in the denominator. If there's only one, then the whole fraction is negative. So you end up with the exact same answer. It doesn't really matter. Another way, sometimes we'll just kind of eyeball it, right? Here's, remember, it's the change in y over the change in x. So if I'm going from 9 to 1, what's happening there? Well, I'm losing 8. And then if that's my 0, if I'm going from negative 7 to negative 2 right here, what am I doing? Well, I'm actually adding 5. So you could just look at it and say, look, that's negative 8, because this is my change in y, over my change in x, 5, which is what I just ended up doing right there. Either way, our answer here is going to be A.